Okay, so here we are in question 1. Write down the period in radians of this curve, 3 tan theta upon 2 minus 3. I'm just going to rewrite that, I think. I'm going to write this as y equals 3 tan a half theta minus 3. And usually with these questions, we've got to understand what these numbers here mean, which I'll call A, 3, B, which is a half, and C, which is negative 3. Well, the A is usually the amplitude. Now, of course, with a tan graph, amplitude doesn't really exist in the same sense as for a sine and cosine, so we can kind of ignore that a little bit. This C here, negative 3, is the shift in the y direction, so that means the graph has been shifted down by 3. And then this thing here, this B, is the number of waves in 180 degrees or pi radians. Okay, now you've got to be a little bit careful here, because if we've got a sine and a cosine, then this number here, this B, would be the number of waves in 360 degrees or 2 pi radians. But because we've got a tan graph, it means that this thing is the number of waves in pi radians. So this is the number of waves in pi radians, or 180 degrees. Now, of course, if we've got half a wave in pi radians, then one wave is going to be equal to 2 pi radians. You just say that again. If half a wave exists within pi radians, then one full wave is going to take up 2 pi radians. And that's what we refer to as the period of the wave. The period of the wave here is going to be 2 pi. Now, if you want a formula that's going to help you to remember that, then essentially you can say that the period t is going to be equal to pi divided by b. In this case, where we are dealing with the tangent graph. Okay, if we were dealing with sine and cosine, it would be 2 pi divided by b. Okay, so here our answer is the period is equal to 2 pi. All right then, well, let's go down. So we want to do part B. On the axis, we want to sketch the graph of this function between minus pi and positive pi, stating the coordinates of the points where the graph meets the axis. Now, they've been really nice here. The way they've been nice is they've already given you the asymptotes of the graph, right? And the asymptotes of the tan graph are usually between minus pi by 2 and plus pi by 2. But of course, remember what we've got here is we've got a graph that's been stretched, that instead of having a period of pi has got a period of 2 pi, and so therefore the asymptotes are at minus pi and pi respectively. Okay, so we're going to have a wave that's going to go between those values. So now what's the other thing we've got to do? Well, we've got to figure out what the x and y intercepts will be. Well, the graph has been shifted down by negative 3, so we should know that the y-intercept is going to shift from the origin down to negative 3. It's probably a good idea just to demonstrate that as well. So what we're going to do is we're going to say the y-intercept is when x is equal to 0, or in this case, theta is equal to 0. And so what we're going to get is y is equal to 3 tan 0 minus 3. And tan 0 is, of course, 0. So the y-coordinate is negative 3. So our y-intercept is there. We can do the same kind of thing for the x-intercept. The x-intercept is always where the y-coordinate is equal to 0. Or rather, in this case, the theta-intercept, isn't it? Sorry. When y is equal to 0, so we're going to get 0 is equal to 3 tan a half theta minus 3. Okay. Oh, sorry, no bracket there. And so therefore, 3 tan theta, or 3 tan a half theta, beg your pardon, is going to be equal to 3. So tan a half theta is going to be equal to 1. And if you do the tan inverse of 1, what you're going to get is 45 degrees. But remember, we're doing with radians, so we're going to get pi by 4 radians. So a half theta is equal to pi by 4 radians. And therefore, theta is equal to twice that, which is pi by 2. So let's try to draw these coordinates on our graph. So what we're saying is we are going to have a x-intercept here, which is at pi by 2. We're going to have a y-intercept at negative 3, so I'll put that there. That's negative 3. And the graph will follow the asymptotes, right? So it'll come up to the asymptote there, and it'll be down the asymptote here. So now all I've got to do is I've just got to join these points up. Sorry if this is going to be a bit messy. Oh dear. Something like that. Oh, that's not great, is it? Okay, something like that. Okay. Okay, so you need to know what the tan graph looks like, right? It's different from sine and cos. And then all you got to do is you've got to find your x-intercept and your y-intercept as usual, and then try to draw the curve that goes through those points. Okay? Okay, so here we are in question 2. We want to write this quadratic here in this completed square form. So how are we going to do that? Well, firstly, we need to take the coefficient of x squared, and we need to factorize out that coefficient. So I'm going to write here 2 bracket x squared plus 5 upon 2x plus 3. Okay, we don't need to factorize out the last term there, so we can just leave that outside the bracket. The next thing we need to do is we need to consider how to complete the square with these two terms here. Now, the way we do that is we look at the coefficient of x, which is 5 upon 2, and we halve that number. If we halve that number, we're going to get 5 upon 4. So then what we do is we take that 5 upon 4, and we write it like this. We've got x plus 5 upon 4 all squared minus 5 upon 4 all squared. Let's clarify what's happened there, right? We take the coefficient of the x, this thing, we halve that number, we put it here, we square it, and we subtract off. So now what we've got to do is just got to expand this and simplify. So we're going to get 2 bracket x plus 5 upon 4 all squared minus 2 lots of 5 upon 4 all squared. Well, 5 squared is 25, 4 squared is 16. So hopefully what you can see is that we're going to get terms cancel off. We can divide top and bottom there by 2. So this is 25 upon 8. And we can think of the 3 as 3 upon 1. And so therefore, if we times top and bottom by 8, we're going to get 24 upon 8. That means that this is going to simplify to give 2 bracket x plus 5 upon 4 all squared minus 25 upon 8 plus 24 upon 8. And of course, that's going to simplify to give minus 1 upon 8. Okay, so we end up here with minus 1 upon 8. Now, the next part of this question is then to state the coordinates of the stationary point. Well, we just got to really look at these two values here, right? 5 upon 4 and negative 1 upon 8. We can say that the vertex is equal to negative 5 upon 4 and negative 1 upon 8. Now, this is the tricky bit, right? Which is getting the signs right. That 5 upon 4, that needs to be negative. The sign is going to change. The y coordinate remains the same. You want to memorize it, which I suggest you do. If you've got a quadratic of the form x minus p all squared plus q, then the vertex for that, the vertex is going to be at e comma q. Right? So for the x coordinate, there's a negative there that you need to consider. All right, now next is we want to solve the inequality. Now it's very tempting, I think, to use the completed square form that you've already done, but I don't think actually that's as helpful. So what I'm going to do is I'm going to expand all of this as follows. I'm going to multiply both sides by 8, so I get 16x squared plus 40x plus 24 is less than 15. And so I get a quadratic 16x squared plus 40x plus 9 is less than 0. And I'm going to factorize this. So 4x and 4x is less than 0. And we're looking for two numbers. They're going to multiply together to give 9. They're going to combine together to give 40. So the way I'm going to choose this is I'm going to go for plus 9 and plus 1, right? Because 4x times by 1 is 4x. 9 times by 4x is 36x. So 36x plus 4x is 40x, which is what we want. Of course, you could use a calculator to find these values. Now, why am I doing this? Well, because I want to basically sketch this graph. And to do that, I want to get the x-intercepts. My x-intercepts are as follows. I've got negative 9 upon 4. And I've got x is equal to negative 1 upon 4. What that means is that if I was to sketch this graph, if I was to sketch it like this, like that. So here is negative 1 upon 4, and here is negative 9 upon 4. my quadratic is going to look oh, there's a nasty. Let me try that again. My quadratic will look something like that. And so what I want to ask is, well, when is this quadratic less than 0? Right? When is that quadratic less than 0? Which is the same thing as saying, when is the y-coordinates less than 0? And the y-coordinates are less than 0 here, everywhere below the x-axis. Okay, so that's the part of the curve that I'm interested in. And so the x-coordinates I'm interested in is everything from here to here. So my solution is going to be x must be greater than negative 9 upon 4, and x is less than negative 1 upon 4. So guys, the key thing I suggest to you is, you could have used completing the square, right, to find these coordinates, negative 9 upon 4 and negative 1 upon 4. That would be absolutely fine. But what I'm trying to emphasize with these questions is you always want to sketch your quadratic. And the reason you want to sketch the quadratic is because it helps you to identify the region that you're interested in, right? If you are looking for anything less than 0, you're going to be below the x-axis. If you're looking for anything that's greater than 0, you are going to be above the x-axis, right? That's the most important thing, okay? Just for the sake of completeness, I'll show you how to use the completing the square method as well. So you had shown that the quadratic was 2 bracket x plus 5 upon 4 all squared minus 1 upon 8. And now I'm just going to set that equal to the 15 upon 8. And so then what I can do is I can get 2 bracket x plus 5 upon 4 all squared is equal to 16 upon 8. And of course, 16 upon 8 is just 2, right? 16 upon 8 is 2. I can divide both sides through by 2, so I get x plus 5 upon 4 all squared is now equal to 1. So if I square both sides, I get x plus 5 upon 4 is equal to plus or minus 1. And so therefore, if I've got plus 1 minus 5 upon 4, that's minus a quarter. If I've got minus 1 minus 5 upon 4, that's minus 9 upon 4. So I get the same x coordinates as I did. But the key thing is we want to identify the region, as I said, because we want to get the right inequality in the end. Okay, thank you. I hope that was helpful. Okay, then here we are in question 3, which is a logarithms question. We are supposed to write this thing here as a single logarithm to base 10. Okay, now there's something I think is quite helpful, a notational issue. LG, lug, means log base 10, right? It's just a shorthand way of writing that because mathematicians are lazy. In the same way, ln means log base e. Okay, so that's all it is. It's just shorthand notation. So we can already see that this thing here, log a, and this thing here, the log 4b squared, is already written as a logarithm with base 10. So the only thing that isn't written as a logarithm base 10 is this 3 here. Well, then there's another trick that's going to be quite helpful to know, which is that we can write log base a is equal to 1, right? In other words, this will work with any base, whether it's base 10 or base 3 or base 4 or base whatever. And so what we could say as well, kind of drawing on from that, is that log base a to the power of n is equal to n. Okay, so what we could do is we could take this 3 and we can immediately replace it and say, okay, this is the same thing as log base 10 to the power of 3. Okay, and the same thing I'm going to do, or rather I'm going to continue writing the rest of the expression. I've got 2 log base na minus a half log base 10 4b squared. Okay, and notice all I'm doing is I'm replacing the LG with log base 10, just to make it really clear that that's the base. All right, then, at this point, what we need to know is we need to know our logarithm rules. Okay, so I'm going to write the logarithm rules down here. So the first rule is that if I've got log A plus log B, that's going to be equal to log of AB, A times by B. Second log rule is that if I've got log A minus log B, then that's going to be equal to log A divided by B. And lastly, third rule, if I've got log A to the power of P, then that's equal to P times by log A. Okay, now the key thing to understand about rules 1 and 2, these two rules here, is they only work if there's no coefficient before these logs, right? So we can't have, for example, 2 log A plus log B, right? They just need to be logarithms with no numbers before them. So what we need to do is actually we need to deal with that 2 here, and we need to deal with this half here. And the way we're going to do that is we're actually going to use the third log rule here. Instead of writing 2 times by log base 10a, we're going to take that 2, we're going to bring it up as a power of a. The same thing is true with this half here. We're going to take that up and bring it up as a power of a half there, basically using this rule, the third rule, but in reverse. So I can now write down that what I've got here is log base 10 to the power of 3 plus log base 10a squared, just going to move a little bit to the right, minus log base 10 4b squared, all to the power of a half. Okay? And then what I can do is I can, I'm firstly going to simplify, I think, this expression here, right? 4b squared to the power of a half. Well, power of a half is the same thing as the square root. What I can do is I can write that as log base 10 to the power of 3 plus log base 10 a to the power of 2 minus log base 10, the square root of 4b squared, which is just 2b. Okay? All right, then, now I can use my log rules. I'm going to use the first log rule here. So if I've got log 10 cubed plus log a squared, then I can use the first rule, the log a plus log b is equal to log a times by b. So here what I'm going to get is I'm going to get log base 10 cubed times by a squared. So just to clarify that, what I've got here is log a plus log b is equal to log a times by b. And then here what I've got now is I've got log a minus log b, right? I've got log a minus log b. So according to the second rule over here, that's equal to log a over b. If I do that, I'm going to have log base 10 bracket 10 cubed is 1,000, a squared divided by 2b. Of course, I can simplify that as log base 10, 500 a squared over b. Okay, and so that should be our answer for part A. Okay, so here we are in part B of our logarithm question. It is given that 2 log base c3 is equal to 7 plus 4 log base 3c. We want to find the possible values of the positive constant c, giving our answers in exact form. Well, the thing we should notice here is that we've got logarithms with different bases. This one's got base c, this one's got base 3. So we need to convert the bases. So we need to remind ourselves what's the formula for doing that. Well, if I've got log base a of x and I want to change it to log base b of x, then I need to divide through by log base b of the old base, a. And the way I recommend that you remember that is on the right-hand side here, the two bases are going to be the same. You're going to have base b and base b. In this particular question, you've got a choice, right? You can either change from log base c to log base 3 or the other way around. And what I recommend is that you change this one because it's more convenient if your unknown value isn't on the base, okay? Hopefully you'll see why in a moment. So we're going to convert log base c3 into log base 3. And the way we're going to do that is we're going to divide through by log base 3 of the old base, c, right? So hopefully what you can see there is we've got the same base on the right-hand side. Well, log base 3 is the same as 1. And so therefore, this thing is actually just the same as 1 over log base 3c. I can take my equation and I can rewrite it. This is 2 times by 1 over log base 3c is equal to 7 plus 4 log base 3c. And what you've got here actually is you've got a hidden quadratic. And to see that, what I recommend you do is use a substitution. Okay? We will say let x equal log base 3c, which means that this entire equation becomes 2 times by 1 upon x is equal to 7 plus 4x. And of course, if we multiply the entire equation by x, what we end up with is 2 is equal to 7x plus 4x squared. And if we were to rearrange that a little bit, we get 4x squared plus 7x minus 2. And quadratics, you can use your calculator to solve. You can use the quadratic formula. You can factorize. I'm going to try to factorize here. So I know I need two numbers that are going to multiply to give -2. That could either be -1 and +2 or the other way around, right? And I think probably what I'll do is a bit of guesswork here. I'm going to call that 4x and x. I think that'll be +2 and -1. The reason I think that is the two numbers 2 and -1 multiply to give -2. But then if I was to expand this, I get 4x times by +2, which is 8x, and I get -x there. So this is going to give me two solutions. X is equal to 1/4, or x is equal to -2. Now, of course, we know that x is actually equal to log base 3c. That was our substitution. So what we've got here is log base 3c is equal to 1/4, and log base 3c is equal to -2. So if we were to do this, then c is going to equal to 3 to the power of 1/4, or c is going to equal to 3 to the power of -2. Now, power of -2 is the same thing as 1 upon 3 squared, and so that's going to be 1 upon 9, and 3 to the power of 1/4 is the 4th root of 3, right? So we just use a little bit of indices rules there. Now let me just check the question. I want to give our exam answers in exact form. Well, I think that's there in exact form. What I'm going to do is I'll just check the mark scheme, just see if that is indeed the way they want it. Yeah, 3 to the power of 1/4 or 1 upon 9. So the way they actually want it in the mark scheme, they write 3 to the power of 1/4, but I mean, that means the same thing as 4 root 3, so I think that should also be fine. And 1 upon 9 is the other solution. Okay? Hope that was helpful too. Okay, here we are in question 4. We've got the straight line y equals 3x minus 11. And this curve here, they intersect at the points A and B. And the point C with coordinates a, -8, where a is a constant, lies on the perpendicular bisector of the line AB. Find the value of A. Right, well, there are a few things that we're going to need to do here. And really the difficulty of the question is actually figuring out what those steps are that we need to take. Now, we're told that this line and this curve intersect at the points A and B, so it's probably going to be a helpful thing to do to find A and B. How do we find the intersection points? Well, intersection points is the solution to simultaneous equations. We've got to solve this and this simultaneously. How are we going to do that? What's the easiest way? Well, we can substitute this thing here, the y equals 3x minus 11, into this thing here. So that's what I'm going to do. I'm going to substitute in, so I'm going to get x bracket 3x minus 11 is equal to 4 minus 3x minus 2x squared. So I'm going to expand the left-hand side. 3x squared minus 11x is equal to 4 minus 3x minus 2x squared. So if we bring everything through to the left-hand side, so I add 2x squared to both sides, so I get 5x squared on the left. I add 3x to both sides, so I'm going to get minus 8x on the left, and I'll subtract 4 from both sides, so I get minus 4 on the left is equal to 0. So there's a quadratic there. And typically we want to factorize quadratics, so I think that we'll probably get 5x and an x, and we're going to want two numbers that multiply together to give -4, but add in such a way that we're going to get a -8 term here. So let's have a think about that. My guess is that's going to be -2 and +2, because we know that +2 times by -2 is -4. If I've got 5x times by -2, that's minus 10x. But here I've got 2 times by x, that's plus 2x, and minus 10x plus 2x is minus 8x. Of course, you can use a calculator, but I always think it's helpful just to keep explaining that as well. So we've got two solutions. We've got x is equal to minus 2/5, and we've got x is equal to 2. All right, like that. By the way, actually, just before I do that, I'll just explain a quick step. This may be obvious to so many of you, but look, here what we've got is we've got this thing multiplied by that thing is equal to 0, right? So how is that possible? Well, there are only two ways, right? Either the 5x plus 2 is equal to 0, or the x minus 2 is equal to 0, right? Because if you think about it, if I've got any number like 3 and I times it by 0, I get 0. Or if I do 0 times by 7, I get 0. So what we're really saying with a quadratic of this kind when it's factorized is this thing times by this thing is 0, which means that either this or this must be 0. So hence 5x plus 2 is 0, which leads us to x is equal to minus 2/5. Or x minus 2 is equal to 0, which leads you to x is equal to 2. I'm sorry if that's a bit kind of tedious for most of you. I just sometimes in my experience, actually, I find that students can get quite far through their studies, but they don't actually understand that. So I'm just doing that for your benefit. Okay, well, if x is equal to minus 2/5 or 2, it's going to be helpful to find the y coordinate. The best way to do that is to use the equation for the straight line, 3x minus 11. So let's just write that down here. So y is equal to 3x minus 11. So if we substitute negative 2/5 into that, then what we're going to get is y is equal to minus 6/5 minus 11. Okay, so that's minus 6/5 minus 55/5, which is minus 61/5. Or alternatively, we're going to get y is equal to 2 times by 3, which is 6 minus 11, and 6 minus 11 is minus 5. Okay, so we've got the two solutions there. Therefore, what we can say is that A has got coordinates minus 2/5, comma, minus 61/5, and that B has got coordinates 2, comma, negative 5, right? So we've got the coordinates for A and B already. Okay, then, what's our next thing that we're going to do? Well, the point C lies on the perpendicular bisector of AB. So how do we find a perpendicular bisector? Well, we kind of need to just understand what we mean by a perpendicular bisector. So let's say we've got our points here. Let's say this is coordinate A, and this is coordinate B. I'm not drawing it to scale, by the way, just to make that super clear. And we've got a line that is connecting them. What we mean by the perpendicular bisector is the line that goes perpendicular to AB. So it's at 90 degrees, like that. Okay. And that goes through the midpoint of AB. So, right, so this coordinate here, that is the midpoint of AB. So if we want to find the equation of the perpendicular bisector, one of the things we need to do is we need to get the coordinate at the midpoint. And then what we need to do is we need to find the gradient that's perpendicular to AB. So let's try to go through those steps, right? So firstly, we're going to find the midpoint of AB. And the way we do that is we add up our two x coordinates. So we're going to get minus 2/5 plus 2, and then we divide those by 2. And then we do the same thing with our y coordinates. We add up our y coordinates, is negative 61 upon 5, plus minus 5, so that's minus 5. And again, we divide those through by 2. So to find the midpoint, we add up the x coordinates, divide by 2, and the same for the y coordinates, add them up, divide by 2. So if I do that, what am I going to get? I am going to get, well, minus 2/5 plus 2, well, that's 10/5, isn't it? So this is going to be 8/5 divided by 2. And then we've got minus 61/5 and minus 5. Well, that's minus 25/5. So that's going to give me minus 86/5 upon 2. And if I simplify that, that's going to be 4/5. And that will be minus 43 upon 43/5. Okay, just to clarify what I've done there, 8 divided by 2 is 4, minus 86 divided by 2 is minus 43. Okay, now having done that, probably what we want to do is we want to find the gradient of AB next. All right. Okay, then, so how do we find the gradient of a line? Well, we do y2 minus y1 is equal to, divided by x2 over x1. So let me just write down that formula there. So gradient is equal to y2 minus y1 over x2 minus x1. So we are going to go up. We're going to do minus 5 minus 61 upon 5. So minus 5 minus 61 upon 5 divided by our x2 minus x1, which is going to be 2 minus 2/5. So 2 minus 2/5. Okay. Well, I think in order to get rid of the fractions, actually, it's probably just easier to multiply top and bottom by 5 in this case. Right? It's going to make our algebra a little bit easier. So this is going to be minus 25 minus 61, so that's going to be plus 61. On the bottom, we're going to get 2 times by 5, which is 10, minus 2/5 times by 5, which is just 2. Okay? All right. And then minus 25 plus 61, well, that's 61 minus 25. So 61 minus 20 is 41, minus 5 is 36. 10 plus 2 is 12, so we're going to get 36 upon 12, which is equal to 3. All right, so we now know that the gradient of AB, so the gradient A and B, which is little m AB, is 3. Well, what we want to find is the gradient perpendicular to that. We want to find this gradient here. Well, how do we find a gradient perpendicular? Well, we need to use the formula m1, m2 is equal to negative 1. So if two gradients are perpendicular, then the product of those gradients is equal to negative 1. So if our gradient of AB is 3, then that means that the gradient that's perpendicular, which I'll write like that, is equal to minus 1 divided by 3. Okay? So we've got the gradient of our perpendicular bisector, right, which is this thing, right? That's the gradient, negative 1/3, and we've got the coordinate that it goes through, which is this thing here, our midpoint. So then what we can do is we can use our formula for a straight line. The formula for a straight line is y minus y1 is equal to mx minus x1. All right, so then we just got to substitute our points into there. So if I do that, so I'm just going to go down here if you don't mind. So y minus y1, so our y1 was minus 43 upon 5. So we've got y minus 43 upon 5 is equal to m, which is minus 1/3, bracket x minus x1. And our x1 was 4/5, so we got minus 4/5. Minus 4/5. Okay, so this is y plus 43 upon 5 is equal to minus 1/3 x plus 4 upon 15. Okay, and if you want, we can rearrange this. We get y is equal to minus 1/3 x plus 4 upon 15 minus 43 upon 5. Well, we can convert that, I think, to 15ths by multiplying 43 through by 3. It'll give us 129. And so therefore, if we just simplify that, we get minus 1/3 x minus, well, 125, minus 129 plus 4 is minus 125 upon 15. I think we should also be able to divide that through by 3 as well to get minus 1/3 x. 125, beg your pardon, not divided by 3, divided by 5, give 25 upon 3. So that's going to be the equation of our perpendicular bisector. And what are we told? We're told that the point C has an x-coordinate of A and a y-coordinate of negative 8. So if we want to find A, what we've got to do is we've got to substitute in y is equal to negative 8. So let's just go down here. All right, so now we're going to say, move across to the right, when x is equal to A, that's an alpha, beg your pardon, when x is equal to A, y is equal to negative 8. So we can say negative 8 is equal to negative 1/3 x minus 25 upon 3, or actually we can replace the x with an a. Really, it's probably what we should do. I'm going to times everything through by 3. So that's, times through by negative 3 actually, to turn everything into a positive. So we get 24 is equal to a plus 25. So a is equal to negative 1. So the coordinates of C are going to be negative 1, comma, negative 8. And that should be our final answer. All right, question 5. This is a binomial expansion style question. We want to find the first 3 terms in this expansion in descending powers of x. We want to give each term in its simplest form. Okay, well, if we've got a binomial expansion, x squared minus 4 upon x squared to the power of 10, what I suggest is that you take each term, the x squared and the negative 4x squared in turn. What I mean by that is this. You're going to start with an x squared to the power of 10. And then in the next term, what you'll have is an x squared to the power of 9. And then in the next term, you'll have an x squared to the power of 8, right? So those powers decrease. You've got 10, 9, 8. And then with this term here, the negative 4 upon x squared, you can write that negative 4 upon x squared to the power of 0, negative 4 upon x squared to the power of 1, and negative 4 upon x squared to the power of 2. And notice that these powers increase 0, 1, 2. Furthermore, you should notice that the 2 powers must add up to give this thing here 10. 10 and 0 is 10, 9 and 1 is 10, 8 and 2 is 10. Okay, lastly, you need to put in the coefficients. Coefficients will be 10c0, 10c1, 10c2. Notice again that those are increasing. And then you just add up these terms. And of course, we've got other terms afterwards, but we're not interested in those. So guys, I think the way you lay out this question is going to be part of the key to your success. So you take one term and you reduce its powers. So 10, 9, 8. Another term and you increase its powers, 0, 1, 2. And then you take the 10c0, the coefficient 0, 1, 2, like that. So at this point, really, all it's about is simplifying our terms. So 10c0 is 1. X squared to the power of 10 is x to the power of 20. And anything to the power of 0 is 1. Next, if we've got 10c1, that's equal to 10. X squared to the power of 9, we multiply the powers, right? We use our indices rule. And if we've got negative 4 upon x squared to the power of 1, that's just negative 4 upon x squared. You need to use the brackets, otherwise you're not going to be right. Okay, then we need to do 10c2. To do that, we need to use the calculator. So let me just do that now. 10c2. That gives me 45. So I've got 45. X squared to the power of 8 is x to the power of 16. And negative 4 upon x squared squared. Well, negative 4 squared is 16. And x squared squared is x to the power of 4. So now if I multiply these things out, I've got x to the power of 20 minus 40, because 4 times by 10. And if I've got x to the power of 18 divided by x to the power of 2, that's x to the power of 16 because I subtract the powers. Lastly, I've got 45 times by 16, which is 720. And I've got x to the power of 16 divided by x to the power of 4, which is x to the power of 12 because I subtract the powers. And I've got other terms as well, but I'm not interested in those. Okay, so that should be the answer for part A. So now let's go down, let's have a look at part B. Hence, we want to find the coefficient of x to the power of 16 in this expansion here. Well, okay, we've got our binomial expansion from the part A multiplied by this thing. So I think what we should do is expand the second thing first. So I've got x squared plus 2 upon x squared all squared. I'm going to do this nice and slow. I'm going to have x squared squared, like that. And I'm going to have x squared times by this 2 upon x squared. And I'm going to have the same thing again. And then lastly, I'm going to have my 2 upon x squared all squared. I'm just doing that slowly because I think a very common fault will be people will just take this, square it, and take that, square it, and that's the answer. And they're going to miss out these terms in the middle. Okay? All right, well, x squared squared is x to the power of 4. Here, if I've got x squared divided by x squared, that's going to cancel off. The same thing here. So I'm left with 2 plus 2, which is 4. And then lastly, what I've got is 2 squared, which is 4. And x squared squared is x to the power of 4. So that's that expansion. So really what we've got is we've got the expansion x to the power of 4 plus 4 upon x to the 4 then multiplied by this whole thing here. But that thing we saw can be represented by the following expansion from part A, x to the power of 20 minus 40x to the power of 16. X to the power of 20 minus 40x to the power of 16. And then what was the last term? 720x to the power of 12. Plus 720x to the power of 12. And we have, of course, other terms, but we're not interested in those. Now, what we're asked to find is we're asked to find the coefficient of x to the power of 16. So we've got to ask ourselves the question, if we were to multiply this out, how would we get an x to the power of 16? Well, there are three ways. Either we can take the x to the power of 4 term and multiply it by this, the x to the power of 12, right? Because x to the power of 4 times x to the power of 12 will be x to the power of 16. Or we can take this term here, the 4, and multiply it by this term here, right? Because that's already an x to the power of 16. Or we can take this term here and multiply it by x to the power of 20, right? Because that will cancel off to give x to the power of 16. So we're going to write out, we've got x to the 4 times by 720 x to the power of 12 plus 4 times by minus 40 x to the power of 16 plus 4 upon x to the 4 times by x to the power of 20. And so if I expand that, I'm going to get 720 x to the power of 16 minus 160 x to the power of 16 plus 4 x to the power of 16. No other terms actually there. And so if I add that up, I'm going to have 720 minus 160. So 720 minus 160. I'm going to add 4. So what I get is 564. So I've got 564 x to the power of 16. And so the coefficient of x to the 16 is 564 there. Okay, we're in question 6, which is a circular measure style of question. We're told that we have a circle with center O with radius r. The points A and B are on the circumference. And the area of the minor sector is 25 centimeters squared. By the way, when we say minor sector, we mean this smaller sector here. The major sector would be this one here. All right? We want to find an expression for the perimeter of P in terms of r. Well, what's the perimeter? The perimeter is going to be this length, which is the radius, plus this length, which is the arc length, plus this length here, which is the radius. So we can say our perimeter is equal to r plus the arc length. Well, we need to know our formulas, right? Firstly, the formula for the arc length is r times by theta. So what we can do is we can replace our arc length there and say this is 2r plus r theta. Well, okay, what we've got now is we've got an expression in terms of r and theta, but what we need is an expression in terms of just r. So what we need to do is we need to get rid of that theta. How can we do that? We can use our second formula. The second formula that we should know is that the area of a sector is equal to a half r squared theta. So I know that the area is 25 because we're told that in the question. So 25 is equal to a half r squared theta, which means if we rearrange, theta is equal to 50 over r squared. So I can now substitute that into here, which means I get 2r plus r times by 50 over r squared. If I cancel off, what I get is 2r plus 50 over r. Okay? All right then. Well, next part, given that r can vary, we want to show that p has a minimum value. So how we find a minimum value? Well, what we're really doing is we're finding a stationary point. And so we're going to write our first statement. A stationary point is when the derivative, dp dr, is equal to 0. So we've got to differentiate our expression. So we're going to rewrite it, first of all, as p is equal to 2r plus 50 r to the power of negative 1. We're going to put it in indices form. So I'm going to differentiate this, dp dr, and I get 2 minus 50r to the power of negative 2. And as we said, we've got a stationary point when dp dr is 0, so I'm going to set this equal to 0 here. 0 is equal to 2 minus 50 upon r squared, right? I've converted back from indices form because now I need to solve. If I rearrange this, I get 50 over r squared is equal to 2 r squared, which means that 25 is equal to r squared, and that means that r is equal to 5. Okay, so r is equal to 5. we can exclude the possibility that r is equal to -5 because you can't have a negative radius. Okay. Now then, we want to find actually what the value of p for this is. So we need to substitute in. So p is 2r plus 50 upon r. So p is equal to 2r plus 50 upon r. And we can say when r is equal to 5, this is going to be equal to 2 times by 5, which is 10, plus 50 divided by 5, which is 10. And so the perimeter should be equal to 20. I think I got that right. Yes, I think that's okay. Lastly, we should show that this is a minimum. How do we show that this is a minimum? Well, we want to find the second derivative. So I'm going to differentiate this again, d2p dr squared, which is going to give me positive 100 r to the power of -3, which is 100 upon r cubed. And actually, you notice that it doesn't matter what r is, right? For any value of r's got to be positive, which means that r cubed is positive. And so 100, which is a positive number divided by a positive number, is a positive number. So because the second derivative is always positive, what this means is we have got a minimum. Okay? So we know that we've got a minimum value when r is equal to 5, and the minimum value for that perimeter is p is equal to 20. Okay, then, so here we are in question 7. The table shows the values of the variables x and y, which are related by an equation of this form, where a and b are constants. And we are asked to use the data to draw a straight line of ln y against ln x. Well, okay, what I've done is I've already used my calculator to calculate the variables ln x and ln y, just to save a bit of time. We're going to plot them now. So 0.4 and 2.62. It's going to be a bit rough on mine. I hope you understand that because it's a bit hard for me to do this. 2.6, I think it's probably going to be like there-ish. 0.7, 3.3. That would be 0.6, 0.7, sort of up there, 3.3-ish here. And 0.9, 3.8, 3.9. There, I guess. And next one. 1.1, 4.3. 1.1 all the way up to 4.3, there-ish. Okay. And 1.39, so 1.4 and almost 5. So go up, sort of there. I think that should be about right. Okay, so we're going to draw a straight line that goes through all of those. See, something like that. Is that good? Yeah, maybe let's try that again. Okay, and let's have a look at the next question. I'm going to use our graph to estimate the values of a and b. Well, essentially, really, what we've got to do here is we've got to understand this thing, the y equals ax to the power of b. So what I'm going to do is I'm just going to go down here, and I'm going to rewrite that out. So y equals ax to the power of b. And then what we're going to do is we're going to log both sides. So I'm going to get ln y is equal to ln ax to the power of b. And I can use the log rules to split this up. I'm going to get ln a plus ln x to the power of b. And the log rule there is the log of a times by b is equal to the log of a plus the log of b. And then I can use another log rule to deal with that b and bring it down to the front. So in the end, what I'm going to get is ln a plus b ln x. And really the essential thing to understand here is that this is actually a y equals mx plus c graph. So if I write this out, ln y is equal to b ln x plus ln a. Hopefully this becomes more clear because I can rewrite this where the ln y is equal to capital Y is equal to m capital X plus c. So if we just do a bit of comparison here, our new variable big Y, that's ln y. Our new variable big X, sorry, is ln x. And what's our gradient m? Our gradient m is the constant b. And what's our y-intercept c? Well, that's going to be ln a. So basically, if we plot ln y against ln x, we should get a straight line, which is what we've seen. And the gradient of this straight line will be equal to b, and the y-intercept will be equal to ln a. So I think probably the best thing to do is to find the gradient first. And the way I'm going to do that, I think, is I'm just going to use the two most extreme points. I'm going to use this point here and this point here. So let's go up. The gradient m is equal to y2 minus y1, so 4.98 minus 2.62. So we just do that, 4.98 minus 2.62, and I get 2.36. Divided by x2 minus x1, so that's 1.39 minus 0.405, so 1.39 minus 0.405, and that gives me 0.985. And if I do that calculation, 2.36 divided by, I get 2.395. So we say that's 2.4. And the key thing is that we said that our gradient is the same as our constant b. So we can just say, okay, b is equal to 2.4. Right, well, how do we get our constant a? Well, we said that ln a is going to be equal to the y-intercept c. So we're going to look at our graph. And it's probably not going to be super accurate on mine because, have to draw it a bit rough. But that looks to me like 1.5, 1.6-ish. And so we say, all right, ln a is equal to 1.6, which means that a is equal to e to the power of 1.6. So I'm going to calculate that on my calculator. E to the power of 1.6 is 4.95, or like roughly equal to 5. Okay, and usually with questions of this type, what you've got on the mark scheme is you've got a range of values. Okay, so I'll just check the mark scheme, see if I'm within the range. So they allow us to have. Okay, so they have the gradient is equal to 2.4. So okay, I was bang on the mark, but it allows anything between 2.3 and 2.5. And okay, yeah, they've also got ln a is equal to 1.6. And so therefore a is equal to 5, but they will allow anything from 4.8 to 5.5. Okay, so you want to try to draw a reasonably accurate graph. You've got the paper in front of you, so it's worth spending a bit of time there, but there is a little bit of leeway in case you make an error. All right. Part C, I want to estimate the value of x when y is equal to 100. Well, the key thing really is to understand that we are estimating, right? We're estimating. So probably the best thing to do is to find out what ln 100 is and see what that gives us on the graph. So I'm going to get here ln 100, and that is 4.605, so 4.6 I'll just say. So I'm going to go up to my graph. I'm going to find 4.6, which is like, I don't know, roughly there, is it? Something like that. I'm going to take me to that point. I'm going to take that point and I'm going to go down. And so I think that's what, 1.2? Again, it'll be a little bit rough, especially on the tablet. So I think that's 1.2. So ln x is equal to 1.2. That means that x is going to be equal to e to the power of 1.2. I'll just put that into a calculator. Oh dear, sorry. E to the power of 1.2 is 3.32. You say 3.3. Okay. Now, again, I'll just check the mark scheme, see what they allow. Mark scheme says, okay, they've got x is equal to 3.42, but they will allow anything from 3.2 to 3.5. Okay, so my answer is within the limits. That's okay. All right. Okay, question 8, which is our vectors style of question. We're given a triangle here, OAB, with OA is the vector A, OB is the vector B. The point X lies on OA such that it's 3/5 along that line. That's that. The point Y is the midpoint, so it's halfway along AB. Want to find in terms of A and B the vector AB. Well, A to B, how can we do that? Well, to go from A to B, I can go from A to O and then O to B. So I think that's the best way to write it. The vector AB is I travel from A to O, and then I go from O to B, right? Imagine walking along this diagram. Now, the vector AO is the same as minus OA. The reason for that is it's just going in the opposite direction, right? If I've got the vector OA, right, it's the same thing as going from A to O, just in the opposite direction, right? So it's minus. All right, so OA is the vector A, OB is the vector B. What we end up here is minus A plus B. Well, then part B, we want to find xy. So we want to go from here to here. Well, I think the best thing to do is use our result from the previous question, right? We can use the vector AB. How can we do that? Well, we can say x to y is the same as going from x to A and then going from A to y. So let's try that. So x to y is the same thing as going from x to A and then going from A to y. Well, now we just need to interpret these, right? What's x to A? Well, if O to x was 3/5 of O to A, so if this length was 3/5 of that, then this length from x to A must be 2/5, right? Because if this is 3/5, that's got to be 2/5. We can say that XA is 2/5 of the vector A. And what's AY? Well, AY is halfway along the vector AB, isn't it, right? Because we said that Y is the midpoint. So this is a half of AB. We can write plus a half of minus A plus B. So if we combine this together, what we've got is we've got 2/5 of A minus a half of A plus a half of B. Well, how can we combine this? We've got 2/5. Well, we're going to turn it into tenths, right? So 4/10 of A minus 5/10 of A plus a half of B. Just got to put lines underneath them to show that they're vectors, by the way. And so this is minus 1/10 of A plus a half of B. And that is my answer. Okay, so we're in the next part of our vectors question here. We've got that the lines OB and XY are extended to meet at the point Z. So the OB is extended all the way up to there, and XY is extended all the way up to there. That's point Z. It is given that YZ is equal to lambda XY. Well, I think it's helpful always to distinguish this. So I'm going to use a highlighter to do that. Let's label that in green, the YZ thing. So YZ is this line here. So we're following that trajectory. And BZ is equal to mu B. So what's BZ? I'll do that in red, I guess. That thing there. Going to be that. Okay. So what are the questions? Well, really, we've got 3 related questions, which is why I've grouped them up. We want to find XZ in terms of lambda A and B. So what's XZ? XZ is we're going from here all the way up to here. So how can I write that? Well, I can say that XZ is the same thing as going from X to Y. And then after we go from X to Y, we're going to go from Y to Z, right? That should make sense, right? Imagine walking along this path. I start at X, I go to Y, then I go from Y to Z. It's the same thing as going from X to Z. Now then, we already know what XY is because we're told it here in the previous part of the question. And we know what YZ is as well because we're told it in this part of our question. It's equal to lambda XY. So what we can do is we can say this is XY plus lambda lots of XY. And so therefore what we've got is we've got 1 plus lambda times by XY. And XY is the thing that we've already calculated. It is minus 1/10 of A, minus 1/10 of A, plus a half of B. All right, so that's part C done there. What's part D? We want to find XZ in terms of mu A and B. So if we're doing that, then what we're doing is we're following the red line. So how can we follow the red line? Well, what I suggest is we start at here, we go from X to O, we go from O to B, and then we go from B to Z. Okay, let's try to write that down. So X to Z can be written as, sorry, that's X to Y, isn't it? Which is a bit silly. X to Z can be written as X to O plus O to B plus B to Z. All right then, well, XO is the same thing as minus OX because we're going in the opposite direction. OB is the vector B. We already know that. And BZ, we're told, is equal to mu B, because that's this part of the question here. Okay, so then what is minus OX? What's this thing here? Well, we were previously told that that's equal to minus 3/5 A. Oh, sorry, it's equal to 3/5 A. So this thing here is minus 3/5 A plus 1 plus mu B. Okay, so that's what we've got for part D. All right, then, hence we want to find the values of lambda and mu. Well, basically what we're saying is we've got two ways of writing the vector x, z. We've got this way and we got this way, and they're basically equivalent. So what we can do is we can compare the coefficients of the vector A and the vector B. Now, if we compare for the vector A, what we've got for this is minus 3/5, and what we've got for this is minus 1/10, but remember we've got to times it by 1 plus lambda. So how can we write this? We've got minus 3/5 is equal to 1 plus lambda, but times by minus 1/10. So what we're going to do is I'll times both sides by -10, so that's going to knock off the negative signs. And it means that this thing is going to become 6, right? Because 3/5 times by 10 is 6, is equal to 1 plus lambda. Beg your pardon there, 1 plus lambda. And therefore, lambda is just equal to 5. So that's our lambda. And then we can do the same thing. We can compare for B. If we compare for B, what are we going to get? Well, for this vector, our B component is 1 plus mu. And for this one, we've got a half, but times by 1 plus lambda. So what we're going to do is we'll write down 1 plus mu, beg your pardon. 1 plus mu is equal to a half 1 plus lambda. We've already calculated that lambda is equal to 5. So 1 plus 5 is 6, divided by 2 is 3. So 1 plus mu is equal to 3, so mu is equal to 2. So those are our two values for lambda and mu. Now, I think this question, in a way, is easier than it looks, but it is quite a tricky question. And I think really the trap is this one here, these two things, because usually what happens is we're used to saying that OB is a fraction of O to Z and XY is a fraction of X to Z. But what's happening here is we're defining BZ and YZ as multiples of OB and XY. So that's what makes it a little bit tricky. Okay, hope that was helpful. Okay, so here we are in question 9, which is a kinematic style of question. A particle P moves in a straight line such that its displacement from a fixed point at time t is given by this expression here. And we want to find the values of t for which the velocity is 0. Well, how is velocity defined? Velocity is defined as the rate of change of displacement with respect to time. It's ds dt. So what we really need to do is we need to differentiate this thing here. Okay, then, how are we going to differentiate this? Well, we've got one function, this, multiplied by another function. In other words, we've got the product of two functions. And when we've got the product of two functions, we need to use the product rule. I'm going to start by defining u as 3 bracket t plus 2. And I'm going to define v as being t minus 4 all squared. If I differentiate u, then what I'm going to get is 3. Okay, so it's 3t plus 6. It differentiates to give 3. And v prime, I differentiate with the chain rule. So 2 as the power comes down. I subtract 1 from the power. Then I differentiate inside the bracket. If I differentiate inside the bracket, I get 1, and I multiply through. Okay. Now, what is the product rule? Helpful for you to know, I think. The product rule is v du plus u dv, right? vu prime plus uv prime. And I recommend, by the way, that you remember it in this order, right? v du plus u dv, because it's the same order as you use for the quotient rule. Okay. All right, next thing. So we just got to substitute in. So if we substitute in our v, we're going to get t minus 4 all squared times by 3. Plus, now if we multiply through here, we're going to get 3 bracket t plus 2 times by 2 times by t minus 4. All right, well, I think it's probably a good idea to factorize, isn't it? We can factorize out t minus 4. If I do that, I get t minus 4, big bracket, 3 times by t minus 4, plus 6 times by t plus 2. Okay, I've got the 6 because I got 3 times by 2 there. Well, I can simplify the big bracket. If I've got this, I've got 3t plus 6t, which is 9t. And I've got minus 12 plus 12, which is 0. I end up there with 9t times by t minus 4. Okay, now the question was to find when the velocity is equal to 0. So this is our velocity. So when is velocity equal to 0? Velocity is equal to 0 when either t minus 4 is equal to 0 or 9t is equal to 0. And of course, that gives us solutions t is equal to 4 or t is equal to 0. So that's when our velocity is equal to 0. All right, then, on to part B. On the axis below, we want to sketch the displacement time graph of P. Well, what is our displacement? Our displacement is this thing here, right? This thing here, 3 bracket t plus 2 t minus 4 squared. Let me just write that down. S is equal to 3 t plus 2 t minus 4 all squared. And this thing is a cubic, and it's a cubic that's already written in factorized form. And so we know that the roots of this cubic are going to be -2. Well, we don't care about that because we don't have negative time. And the other root will be when t is equal to 4. But notice this is actually going to be a repeated root, right? Because we've got a squared here. So when we've got a repeated root, what it means is that it doesn't really cut the axis, it just touches the axis. So what we expect is that when t is equal to 4, our curve is going to come down. It's just going to touch the axis like that. Okay. All right then. So we've got that. What's another thing that would be helpful for us to do? Well, we've already stated in the previous part of the question that we've got a stationary point when t is equal to 4 and when t is equal to 0. Okay. So if we've got a stationary point when t is equal to 0, then what's that going to look like? Well, we should probably find out what happens when t is equal to 0. So we'll write that here. T is equal to 0. S is going to be equal to 3 bracket 0 plus 2, which is 2. 0 minus 4, so it's minus 4 all squared. And so that's going to be 4 squared is 16. 16 times by 2 is 32. Times by 3 is 96. So we're going to cross the S axis here at 96. But my point from earlier is this is also a stationary point, right? So actually the curve is going to do something like that at that point. All right, so if we would imagine we were to have a cubic curve which is kind of doing that, comes down then. I'm going to mess this up a little bit. Sorry about that. It's quite hard to draw with the tablet. It's going to look something like that. And come around, it's going to touch there. It's going to go up to this point here. Okay, and it may be wise just to find out what the value is when t is equal to 5 as well. So when t is equal to 5, s is going to equal to 3 bracket 5 plus 2, which is 7, times by 5 minus 4, which is 1 squared. So that's going to be 21. So the coordinate here, that is going to be 21. Okay, now obviously we don't have negative time, so I suppose if we're being complete, we want to get rid of this thing here because that doesn't exist. Okay, but that should be what our graph is going to look like. Okay, then let's move on to the next part. Let's move on to part C. We want to sketch the velocity time graph. Well, velocity we've already found. So we got that function earlier on in the question. That was t minus 4 times by 9t. So let's write that down. So velocity is given by 9t times by t minus 4. So that graph is a quadratic, isn't it, right? And it's a quadratic which is going to have x-intercepts here, right, at the origin, and at t is equal to 4. So that's going to be the x-intercepts. And this is going to be a positive quadratic. So we just have to really connect the points like that. Okay. Like that. And if it's a positive quadratic, then the vertex point is going to be halfway between the roots, right? So that's going to have a coordinate of 2. So we can probably also find the velocity when t is equal to 2. I think that'd be a helpful thing. So we say when t is equal to 2, the velocity is going to be equal to 9 times by 2, which is 18, times by 2 minus 4, which is minus 2. So that's going to be equal to minus 36. So we can label that as being minus 36. And we probably also want to do it when t is equal to 5, I think, just to be complete. When t is equal to 5, velocity is equal to 9 times by 5, which is 45, and 5 minus 4, which is 1. So this coordinate here is going to be 45. So I'm just going to label that, dot, 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 dot. Okay. When t is equal to 5, the velocity is equal to 45. Okay, and that should be our expression for the velocity time graph. All right, lastly, part D. We want to find an expression for the acceleration of p at time t. Well, what is the definition of acceleration? Acceleration is the rate of change of velocity with respect to time. So we've already got velocity, right? Velocity was that 9t bracket t minus 4. So let's write that over here. Velocity was equal to 9t bracket t minus 4. I think I'll just expand it. That's going to give us 9t squared minus 36t. So if we're going to differentiate this, then a, which is dv dt, is going to be 18t minus 36. So in other words, what we're going to get there is a straight line, right? A y equals mx plus c. So on the axis below, we want to sketch that acceleration time graph. So we want to sketch 18t minus 36. Well, if we look at that, we want to find the x-intercept and the y-intercept, right? So we can say when t is equal to 0, a is going to be equal to minus 36. That's like the y-intercept. So I can put that, I don't know, put it here, minus 36. What's the x-intercept? Well, the x-intercept is going to be where a is equal to 0. So when a is equal to 0, sorry about the bad writing, 0 is equal to 18t minus 36. So 36 is equal to 18t, so t is equal to 2. So we're going to label that point there, and call that 2, I guess. And so our line is just going to go straight through like that, like that. Okay? And probably we can label what happens when t is equal to 5. I suspect that might as well just do it for the sake of completeness. Right, give the examiner more information than he asked for, I think. So we're going to get 5 times by 18, which is 90, minus 36. So that would be 60, 54, I think. Okay, let me just double check that. Yeah, 90. Yeah, 54. Okay, so that should be our answer for part D. Basically, I think this question actually looks harder than it actually is. Really what you're being asked under the guise of a kinematics question is to please sketch a cubic, please sketch a quadratic, and please sketch a straight line. Okay, if you can do that, then hopefully this question shouldn't be too bad. Okay, so here we are in question 10, which is a trigonometric identities style of question. We want to show that cos to the power of 4 theta minus sine to the power of 4 theta plus 1 is equal to 2 cos squared theta. Now, the way you want to approach identities questions is you want to take the left-hand side and manipulate it so that you get the same thing as the right-hand side. In other words, don't try to think of this as an equation where you can move things left and right. What you want to do is you want to start with the left-hand side. So LHS is equal to cos to the power of 4 theta minus sine to the power of 4 theta plus 1. And you want to manipulate that until eventually what you get is this thing here. Now, one other thing, when I'm doing these questions, I prefer to write cos as C and sine as S. I just think it makes it tidier and my head doesn't get too jumbled by writing so much stuff on the paper, but it's up to you. Now, in order to do this question, really you need 2 identities. You need to know that sine squared theta plus cos squared theta is always equal to 1. And another thing which is very helpful and will be useful in this question is if you've got a squared minus b squared, you can write that as a plus b times by a minus b. Right? That's a really useful thing to memorize, because if you look at our identity here, or sorry, look at our expression here, what we've got is we've got something squared minus something squared, right? C to the power of 4 minus s to the power of 4. What I can do with that is I can rewrite it as c squared plus s squared times by c squared minus s squared, right, plus 1. And why is that convenient? Well, because this c squared plus s squared, sine squared plus cos squared, is equal to 1, according to that identity there, right? So what we've really got is we've got 1 times by cos squared minus sine squared plus 1. Well, then we're very, very close, aren't we? Because this is cos squared minus sine squared plus 1. So what's the thing we really need to get rid of? Well, we need to get rid of the sine squared. Well, if we use this identity here, sine squared plus cos squared is equal to 1, then we just got to rearrange that a little bit to get sine squared theta is equal to 1 minus cos squared theta. So I can replace my sine squared with 1 minus cos squared. So I've got here cos squared minus bracket 1 minus cos squared plus 1. And so that's going to give me cos squared minus 1 minus cos squared. So that's plus cos squared plus 1. And cos squared plus cos squared is 2 cos squared. And minus 1 plus 1 is just 0. So this thing here is 2 cos squared theta. Now, I've obviously written it out a lot longer than I think hopefully you guys should take, but I just want to make every single step clear. I think that's the easiest way to do this particular question. On the other hand, there are a couple other alternatives in the mark scheme, which I will also go through. So I will, for example, just do one of those. So we've got cos to the power of 4. Sorry, we'll say again, left-hand side is equal to cos to the power of 4 theta minus sine to the power of 4 theta plus 1. Just make sure I got that right. Yeah. Well, what I can do is I can treat that sine to the power of 4 as sine squared squared. And as I said, and I can treat, sorry, beg your pardon, the cos squared as cos squared squared. Rewrite that as that. Okay. And this means that I can replace either the cos squared with 1 minus sine squared, or I could replace the sine squared with 1 minus cos squared. Well, I think what the sensible thing to do is to get rid of the sine squared. So I'm going to write this as cos to the power of 4 minus 1 minus cos squared squared. Okay, again, using the identity that sine squared plus cos squared is 1. And then I can expand that bracket there. So that's going to give me 1 minus 2 cos squared plus cos to the power of 4 plus 1. And so hopefully what you can see is I'm going to get a cos to the power of 4 minus cos to the power of 4. And so what I'll be left with here is minus 1 minus 2 cos squared, and then plus 1. What I end up with is 2 cos squared theta. Okay? All right, now you've got choices how you do these questions. In many ways, it doesn't really matter what you do. But I personally think that the first way is the easier way. And certainly if I was doing a question and I saw something like cos to the power of 4 minus sine to the power of 4, something like that, then I would be wanting to use this rule here. Okay? Okay, so we're in the second part of our trigonometric question. We want to solve this equation here for phi is between minus 3 pi and plus 3 pi, giving our answers in terms of pi. Now, really what we've got to understand is that this expression here, we should recognize from part A, can be rewritten using our trigonometric identity. So what we should see is that this whole thing can be replaced with 2 cos squared phi by 3. Okay? So we're solving 2 cos squared phi by 3 is equal to a half. And we can rearrange that. We get cos squared phi by 3 is equal to a quarter. And then we can square root both sides. So we're going to solve cos phi by 3 is equal to the square root of a quarter, which is plus or minus a half, right? Because if we square root 4, we get 2. Now, at this point, I always strongly recommend that you use a graph. And in order to use a graph, I think you should use a substitution. So I'm going to say let theta, I guess, or let u, we'll call it u, equal phi by 3. That means that this problem now becomes cos u is equal to plus or minus a half. And previously, we had boundaries between minus 3 pi and plus 3 pi. Well, if phi is equal to, if u is equal to phi divided by 3, we could say that phi is equal to 3u, right? So our boundaries that we're considering between minus 3 pi and plus 3 pi, we can change these so that we're looking for solutions for u, which are between minus pi and plus pi. So just to clarify, what we're doing is I've turned this problem with phi, okay, into a problem with u. So now we're solving cos u is equal to plus or minus a half, and that means we're looking for solutions in u which are between plus and minus pi. Okay then, well, the best way to do that is to draw a graph. So I'm going to draw my cos graph. So cos graph like this, okay, and like that. And is pi by 2, pi, I guess 3 pi by 2, even though we don't need it, pi by 2, beg your pardon, and minus pi by 2, and minus pi. So if I was to draw my cosine graph, and it's going to look something like that, because it starts at 1, go down to there, like that. Like that. And so we want to solve when the cos graph is equal to plus u and, is equal to plus a half and minus a half. So I'm going to draw the line of a half, which is like that, and the line of minus a half, which is like that. Okay, so this is the line a half and minus a half. So if we want to solve where cos u is equal to plus a half, then that's going to be given by these intersections here and here. And if we want to solve it when cos u is equal to minus a half, that's going to be these intersections here and here. Okay, so what can we do? Well, we can find our first solution, right, by using the cos inverse. So u is going to be equal to cos inverse of a half. And if we do that and we're using degrees, then we'll get 60 degrees. But if we're using radians, we're going to get pi by 3. So this coordinate there is going to be pi by 3. Okay, well then, how could we find, for example, this coordinate? Well, hopefully we should notice that the y-axis here is a line of symmetry. So this coordinate pi by 3 is symmetrical with that coordinate. So this thing here is going to be minus pi by 3. Okay, we've got another solution there. Okay, then, well, what happens if we're looking for solutions with the intersection with minus a half? So we're trying to find these points here and here. Well, again, we could probably do the cos inverse of minus a half. But hopefully you just recognize also a bit of symmetry again, right? If this distance here is pi by 3, okay, then the distance from here to here must also be pi by 3, right? So in other words, that distance from this point to this point must also be pi by 3. So this coordinate is going to be pi minus pi by 3, which is 2 pi upon 3. And again, using symmetry, this coordinate will be negative 2 pi upon 3. So that coordinate there will be negative 2 pi upon 3. So what do we end up with? We end up with the following set of solutions. We've got that u is equal to minus 2 pi upon 3, minus pi upon 3, pi upon 3, and 2 pi upon 3. But remember, we don't want solutions for u. What we want is solutions for phi, right? And phi is equal to 3 times u. All we've got to do is just got to take all of these solutions and times them by 3. Well, that's going to be pretty easy. Minus 2 pi upon 3, if we times it by 3, is minus 2 pi. Minus pi upon 3, if we times it by 3, is minus pi. Pi by 3 times by 3 is pi. And 2 pi by 3 times by 3 is 2 pi. So these should be all of our solutions for phi. Now, guys, I suspect that quite a lot of you are going, hang on, that's quite a long-winded solution. Can't I just use my, my quadrant method or whatever, or can't I just use a calculator? I really recommend that you use graphs to solve all these trigonometric problems, okay? I generally find that students who use the quadrant method, what happens is, in a way, they don't really understand it, right? And if you don't understand it, what happens is you usually end up guessing. I think it's a bad idea to guess. I think it's always better to try to understand and to know. And what I find is that if you use the graph, even though it's hard and it takes a little bit of time, at least it's logical, right? In other words, you can understand that what you're finding is intersection points. And you can understand that you can use the properties of symmetry to get the points that you can't find easily with a calculator. So that's what I recommend. The other thing is you have to learn how to sketch cosine and sine graphs anyway, right? That's also what you're going to be examined on. So I just think it's good practice. Okay. All right, guys. I hope you found that paper helpful. If you are finding these papers useful, please do like, please do subscribe, comment, pass it on to your friends. And I wish you all the best with your studies.